thanks for checking in and welcome to your next math video lesson. If you're following along in the textbook, this is lesson 5-3. This is on page 234 in the book. I would highly suggest that you write these notes down today because we're going to start talking about something new in this unit that we've not talked about yet. Up until now, we spent a lot of time solving different kinds of equations, one-steppers and two-steppers and multi-steppers, and all of those equations had an equal sign in them. Well, starting today, we are going to be working with things that are called inequalities. And as you can see here in the green definition, an inequality is a math problem that compares two quantities, right, which that means two amounts, that are not equal. So we're not going to be seeing equal signs today. We're going to be seeing inequality symbols. And down below this here in red, we have our inequality symbols. This one right here, this is the less than. This is the greater than. This guy here, less than or equal to. And last but not least, over here on the far right, greater than or equal to. So today, one of the things you're going to be doing is you're going to be reading some scenarios and you're going to be turning them into math problems using these inequality symbols. So, for example, you can see here, if I scroll down a little bit, the first scenario for representing an inequality is this one. The DVD costs more than $15. That means we don't know exactly how much it costs, but we know that whatever the cost is, that's our mystery number, that's C. The cost is C. We do know that it is more than $15. It might be $15.01, it might be $20, but the cost of the DVD, C, is greater than 15. That's an inequality that represents that real life scenario. The cost of the DVD is more than $15. So C is greater than 15. The next one, we're talking about how much a dog weighs. We don't know how much the dog weighs. We're going to use W to represent the unknown weight of the dog. But we do know this, that the dog weighs less than 50 pounds. The dog weighs less than 50 pounds. That means W is less than 50. Whatever his weight is, it is less than 50. So here you can kind of see how we can use inequality symbols to represent real life situations. Okay, so it's like a mystery number and we don't know exactly what the number is. Let's try some on our own. The height requirement is greater than or equal to 40 inches. Okay, so we must be at Great America, right? We're trying to ride some rides. And the height requirement, so your height, let's call that H, is greater than or equal to, this is greater than or equal to 40 inches. That means your height, however tall you are, has to be greater than or equal to 40 inches. You could be 41 inches, you could be 50 inches, you could be 65 inches tall, as long as it's greater than or equal to 40 inches. That means if you are 40 inches tall, you could ride this ride. Let's look at the next one, the speed limit. We don't know what it is, but we know that it's less than or equal to 30 miles per hour. So we must be driving through a neighborhood, and whatever the speed limit is, let's call that S for speed limit, has to be less than or equal to 35 miles per hour. That means you can go any speed as long as it is less than 35 miles an hour or equal to 35 miles an hour, and you are not in danger of getting a ticket for speeding. If you go anything over 35, you are in danger of getting pulled over for speeding. Let's look at another one. A student must have at least 10 hours of driving time in order to take the driving test. You have to have at least 10 hours of driving time. Could you have 5 hours of driving time? No, that's not enough. At least 10. Could you have 11 or 12 or 13? Yes, you could. So the T, the driving time that you need, has to be greater than 10 hours. Or it could be equal to 10 hours. Your time has to be at the very least 10 hours. It could be more than that. Another way to write this would be to say that 10 is less than or equal to the time that you need behind the wheel. So you have to be very careful when you're reading some of these. It's almost like they're written backwards of what they mean. If it says at least 10 hours, that means 10 is the very limit, the lowest you can go. If it says at most, that would mean that's the highest you could go. So you're looking for values less than that. So you need to be careful as you're reading through some of these phrases today. Let's look at some true or false scenarios involving inequalities. It says true or false. 2t plus 8 is greater than 7 if t is equal to 1. That means you're going to treat this basically like you would treat it if it was a plain old equation. You're going to substitute in the value for t to be 1, just like that, and then plus 8, and then greater than 7. Notice it's not the equal to. And now we're going to solve it just like we would, using order of operations. 2 times 1 is 2. And 2 plus 8 is 10. And now you have to ask yourself, does this make sense? Is 10 greater than 7? Yes, 10 is greater than 7. So this is true. That inequality is true if t is equal to 1. Now, if you change the value of t, that might change your true or false. Let's look at the next one. P minus 42 less than or equal to negative 2 if P is 40. So you kind of have to read like a comma there, right? This is like, this tells you what to substitute in for the variable P. So let's go plug in a 40 for the P, and let's do the math and see if it makes sense. 40 minus 42 less than or equal to negative 2. I do the math. 40 minus 42 is negative 2, less than or equal to negative 2. Is it true that negative 2 is less than or equal to negative 2? Yes, it is. It's true because of the equal to part. Negative 2 is equal to negative 2, so that is true. Let's try another. 3 plus x is less than or equal to 12 if x is 6. I don't know, let's see. I'm going to substitute the 6 in there. Nothing else is going to change. 3 plus 6 is 9. Is 9 less than or equal to 12? Is 9 less than or equal to 12? Yes, it is. That is true. Another true one. Careful, they're not all going to be true. Let's try this guy. Y minus 7 is less than 10 if y is 17. So let's plug in a 17 for the y and see if it works out. 17 minus 7 is 10. Is 10 less than 10? No, 10 is not less than 10, so this one is false. So don't be surprised if you see some true or false scenarios today as we start working with inequalities. And then from here we go into graphing inequalities on a number line. Now this can be a little tricky if you don't do what I suggest you do. A lot of kids have a hard time with this unless they do my little trick. Okay, here's what it says. Graph each inequality on a number line. And then I give you some hints. Looking right here at the top row, right here, this is where my eyeballs are. If you see a greater than or a less than symbol, you will need to have what's called an open circle. That's where you put a circle on your number line and you don't shade it in. Now, looking at the second red line, now my eyeballs are here. If greater than or equal to or less than or equal to, right? Then you have what's called a closed circle on your number line. That's where you're going to make a circle and you're going to actually shade it in. So what are we talking about, this graphing on a number line? Well, here are some examples. For the first one, think about the inequality where A would be greater than 6. There is an endless number of numbers that are greater than 6. So I draw a number line, I put an arrow on each end, and I put a hash mark right in the middle, and I put the number 6. So if this was a number line, this would be 5, this would be 4, 3, 2, 1, 0, so on and so forth. And then going the other way, obviously you'd have 7, and we'd be counting up to 8, 9, 10, 11, so on and so forth. But the inequality that's being represented here says A, whatever A is, it can be any number, as long as it's greater than 6. Where are the numbers that are greater than 6 on this number line? Some examples of numbers, and this is the little trick that I try to teach kids to do. List some numbers that make sense. Think of some numbers for A that are greater than 6. Oh, 7 is greater than 6. 10 is greater than 6. 100 is greater than 6. And somehow, if you put those numbers down, it helps you when you look at a number line and you have to decide which way you're going to shade this number line. You're literally going to use your pencil or your pen or your highlighter, and you're going to shade one half of the number line, either going to the right or to the left, to indicate where these values would be that are greater than 6. So for this one, greater than 6, like 7 or 10, that would be going to the right, and I would shade like this, make it nice and dark. Now I look at my symbol, and it's the greater than symbol. That means I need an open circle on 6, and you don't color it in, because it's not equal to 6. 6 is not included in our data set. Okay, so let's look at the next one. Think of numbers for x that would be less than -1. What are some numbers that are less than -1? Well, -2, -5, -10, all of those are less than -1. So here's my number line going right to left. I put my little hash mark in the middle. I put my little -1. Now let's remember, this would be a 0, this would be 1, this would be 2 and 3, and this would be -2 and -3 and -4, so on and so forth. Now hopefully that helps you figure out which direction you would need to shade to show values that are less than -1. Those would be going to the left, so I would shade this way. And I look at my symbol, it's the less than symbol. That means I have an open circle. I do not color it in because I am not including -1 in my shading. Okay, let's look at the next one. X has to be greater than or equal to -2. What are some numbers that are greater than or equal to -2? 5 is greater than -2. 0, -2. Actually is greater than or equal to -2. So I think about my number line, those values would be to the right. Shade, 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 color, 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 blah, 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 like so. And I look at my symbol, and it's the greater than or equal to, and that means I fill the circle in. Because now I am including -2 in my numbers that would work for the variable. Let's do another. X is less than or equal to 0. What are some numbers that are less than or equal to 0? Well, 0 is equal to 0. -1 is less than 0. -10 is less than 0. So on a number line, where would those values be? They would be to the left. So you would shade this away. And because it is the equal to, less than or equal to, we are including 0 in our data as a possibility, and you shade it in, closed circle. Almost done. Let's see if we can go the other way. Here, some inequalities have already been shaded and graphed for you. Let's see if we can come up with the scenarios or the inequalities to represent these situations. You can use any variable you want, so I'm probably going to use different variables. If I'm looking at the first one here where they're showing the 5 and they're showing the shading to the right, what they're telling us is that 6 would work, and 7 would work, and 8 would work, and 9 would work. So basically, we are allowed to choose any number. I'm going to say M, as long as it is greater than or equal to, right, because it's shaded in, greater than or equal to what? 5. Any number that's greater than or equal to 5 is being covered by this graph. Let's look at the next one. I'm going to use A. I like A. And I look at my graph, they're shading to the left, so this would be like a 1, this would be a 0. We're talking numbers that are what? Less than 2. Are we including 2? No, that's an open circle. So I'm going to say A represents my numbers as long as they are less than but not equal to 2. 2 more and then we're done. Let's do J. I like J. And I look at my graph and I see I have a closed circle and I'm including all values that seem to be less than -3 and including -3. So J has to be less than or equal to -3. Any number that's less than or equal to -3, those are the numbers that are included in my graph. Last one. Let's do N. So these are all my N's. Open circle, so I'm not including -11, but I am talking about values like -10, -9, way up here might be +8, right? So these numbers are greater than, but not equal to -11, okay? So boy, we've talked about inequalities, we've talked about true and false inequalities, we graphed inequalities, and we interpreted graphs of inequalities. Whew, that's a lot in one lesson. This is what we'll be doing in class, and kids usually laugh when they see my little reminder there for how to shade circles because they think that those look like faces. You know what? I think they do too, and I think they're kind of funny. And if you want to draw those at the top of your notes or at the top of your homework paper, I think that would be a really super duper smart idea. It just helps you remember when do we shade the circle in and when don't we shade the circle in. All right, so I will see you in class where we will work on these skills. Thanks for watching.